Next example, find integral surface of x cube p y plus y in bracket 3x square plus y cube is equal to z 2x square plus y passing through the curve x naught is equal to 1, y naught is equal to s, z naught is equal to s, s 1 plus s. So this is the given differential equation. Compare with the uh, standard differential equation, capital P into small p plus capital Q into q is equal to r. So we get p is equal to x cube, q as a y in bracket 3x square plus y, r capital R is what, z in bracket 2x square plus y. Then the auxiliary equation is what, dx by p dy by q dz by r. Substitute p q r, and this is the equation number second. Now we have to find the two linearly independent solution of this auxiliary equation, dx by p dy by q dz by r. Okay, this equation number 2. So choose multipliers 1 by x minus 1 by y, 1 plus and 1 plus 1 by z. So we have each ratio is equal to 1 by x dx minus 1 by y dy plus 1 by z dz divided by x cube. A 1 by x into x cube is x square. Then 1 by y into y. So this becomes 3x square uh, minus y minus 3x square minus y, because minus 1 by is multiplier. And 1 by z becomes plus 2x square plus y, and this is equal to 0. And therefore we have 1 by x dx plus 1 minus 1 by y dy plus 1 by z dz is equal to 0, integrating. So log x minus log y plus log z is equal to log c1. Then log a minus log b is log a by b, and log a plus log b is log a plus log a into b. So x into z divided by y. Log x plus log z is log x into z, and minus log y means divided by y, and cancel log of both sides. We have x into z divided by y is equal to c1 as the equation number 3. For second solution, consider the first two ratios. That the first two ratio dx by x cube and dy divided by y in bracket 3x square plus y. So z is absent in these two. So we have, after simplification, that is shift this 3x square plus y to right side, divided by x cube into dx is equal to 1 by y dy, and this is after dividing x cube by separately, we have 3x square by x cube is 1 by x dx, and plus y by x cube dx minus 1 by y dy is equal to 0. So multiplying by x cube y throughout, so we have 3x square y dx plus y square dx minus x cube dy is equal to 0, and then 3x square y dx minus x cube dy divided by y square plus dx is equal to 0. That is shift this y square divided by y square throughout, then divided by y square throughout, we have this, and this is the derivative of x cube by y. This is the derivative of x cube by y plus dx is equal to 0. So the chart of that tricks, that the derivative of x cube by y is this. So and plus dx is equal to 0. So integrating, we have x cube by y plus x is equal to c2. This is equation number 4. So we have the two linearly independent solution 3 and 4. So this, suppose u as the x into z by y is equal to c1, and v as x3 by y plus x, this x3 by y plus x and c2, and this 2 forms the general solution of equation number 2. Now the general solution of 1 is what, f of u is equal to 0, that is f of xz by y comma x cube by y plus x is equal to 0. Now we have to find the integral surface passing through the given curve. The given curve is what, x naught is 1, y naught is s, and z naught is s 1 plus. So substitute x as 1, y as s, and z as s in bracket 1 plus s in equation number 3 and 4. So equation 3 becomes s plus 1 is equal to c1 after substituting x, y, z as 1, s, and s in bracket s plus 1 plus s. So we have this, and equation 4 becomes, after substituting these values in equation 4 is what, Equation 4 is x cube by y plus x is equal to C2. So x cube by y, x cube, x is 1. So 1 cube is 1 by s plus 1 is equal to C2. So 1 plus s by s is equal to C2. Now from these two equations, that is s plus 1 is equal to C1 and this 1 plus s by s is equal to C2, where to obtain the relation between C1 and C2. So substitute s plus 1 and C1 in this equation. So we have C1 and substitute s as C1 minus 1. S as C1 minus 1 is equal to C2, and therefore C1 is equal to C2, C1 minus 1. That after simplification we have C1 C2 minus C2, and then C1 C2 minus C2 minus C1 is equal to 0. This is the relation between C1 and C2. And then substitute C1 as xz by y and C2 as x cube by y plus x. Similarly, here C2 substitute C2 and here substitute C1. And this is the required integral surface, that is the integral surface passing through the given curve. So same type examples for assignment, that find the integral surface x in bracket z plus 2p x plus x into z plus 2yz plus 2yq is equal to z plus 1 passing through the core. X naught is equal to s square, y naught is 0, z naught is 3s. That is, first find the general solution of this Cauchy linear differential equation Pp plus Qq is equal to r, and then that is right, the auxiliary equation dx by p capital P dy by capital Q and dz by r capital R, and then find their two linearly independent solution, that is suppose equation number 3 and 4. And so from equation number 3 and 4, after substituting x as x square, y as 0, z as 3s, find the relation between C1 and C2, and then we have the solution of this problem. Then similar problem, that x plus z dab by z by dab x means p plus y plus z dab by z by dab y means small q is equal to z, right, is equal to minus z. So this is again Cauchy linear differential equation Pp plus Qq is equal to r, right, capital P capital Q capital R, right, the auxiliary equation dx by p dy by q dz by r, find their two linearly independent solutions, that is suppose equation number 3 and 4. And out of so from equation number 3 and 4, we have to find the curve, integral surface passing through this curve, x square plus y square is equal to a, z is equal to 0. So substitute x as a cos t, y as a sin t, and therefore we have a square cos square t plus a square sin square t. If the equation is x square plus a y square is equal to a, then substitute a as root a into cos t and y as root a into sin t, and that then we have root a square is a cos square t plus a sin square t. Take a as common, so cos square t plus sin square t is 1. So if at this place if there is a square, then write this a x as a cos t, y as a sin t. X square plus y square is a, therefore write x is equal to root a into cos t and y as root a into sin t, z as 0. So from equation 3 and 4, find the, after substituting these values of x and y and z, that x as root a cos t, y as root a sin t, z as 0, find the relation between C1 and C2. So this problem is of this type, x square plus y square is equal to 1. So the problem is, this is the problem, that x square, the given curve is what, the equation of curve is what, x square plus y square is equal to 1 and z is equal to 1. Okay, x square plus y square is equal to 1. So what is the substitution? X is sin t and y is cos t. Okay, and now we have sin square t plus cos square t as 1 and z as 1. So in this problem, substitute x as root a cos t, y as root a sin t, and z as 0, and find the relation between C1 and C2. We have the solution. Okay, the same type problem, p minus q x plus y. So write it, this equation in the form x plus y into p minus x plus y into q is equal to z. And so capital P is x plus y, capital Q is minus in bracket x plus y, and capital R is z. Then write the auxiliary equation and find the general solution of that auxiliary equation. And then we have to find the integral surface passing through the curve x plus y plus z is equal to 0 and x is equal to z square. So take z as t, x as t square, and y as minus t square. So what we have, x plus y plus z becomes 0 and x is z square. So x is, suppose z is t, then x is t square and y is minus t square. So after substituting these equations, these values of x, y, z, find the relation between C1 and C2. So solve all these three problems. Then this is the PDF of our book, reference book, that is origin of the first topic is what? Origin of the first order partial differential equation. That is the formation of partial differential equation. So this is the formation of partial differential equation. So suppose x square plus y square plus z minus c bracket square is equal to a square. So a and c are arbitrary constants and we have to eliminate these arbitrary constants. So differentiate with respect to x and with respect to y. We have these two equations, and by using these two equations, we have, that is multiply by this by q and this is by p, and subtracting we have yp minus xq is equal to 0, and this is the uh, required partial differential equation of first order. Okay, so this is the formation of, we have to eliminate the constant c and a. So suppose this is the, actually this is the solution of the problem. So this is the corresponding partial differential equation. So z is equal to x plus a y plus b, that is we have to eliminate a and b and we have to find the corresponding partial differential equation. So 2z ax plus y bracket square plus b, eliminate, that is differentiate this equation with respect to x, with respect to y. Suppose this is the equation number 1, then differentiate with respect to x, equation number 2, differentiate with respect to y, equation number 3, and from equation number 1 to 3 we have to eliminate these arbitrary constants a, b. Okay, solve all these problems. The second type problem, z is equal to x into y plus f of x square plus y square. Now we have to eliminate the function f, arbitrary function here, and we have to form the corresponding partial differential equation. That is again differentiate with respect to, this is the equation number 1, differentiate with respect to x and then with respect to y, and from equation number 2 and 3 we have to eliminate this function here. Okay, so already the answer of these problems are given. Z is equal to f of x into y by z. So this last problem, f of x square plus y square plus z square comma z square minus 2xy is equal to 0. This is of the type f of uv is equal to 0. So denote x square plus y square plus z square as u and z square minus 2xy as v, and then use the formula that small p dabba uv divided by dabba yz plus small q dabba uv divided by dabba uh, x z is equal to dabba uv dabba xy. Okay, and substitute the values of that Jacobian, we have the answer. So this is the problem of the type f of uv is equal to 0. So use that standard formula to obtain the corresponding partial differential equation. Find the general solution of the differential equation. So this is about the first topic, that formation of differential equation, and these are the problems for exercise. Then find the general solution of the differential equation. X square dabba z by dabba x plus y square dabba z by dabba y is equal to x plus y into z. So this is the Cauchy linear differential equation. Dabba z by dabba x is small p, dabba z by dabba y is small q. So this is the problem of the type Pp plus Qq is equal to r. So compare that equation with the standard differential equation. Pp plus Qq is equal to r. Write the values of capital P, capital Q, capital R. Then write the auxiliary equation, dx by p dy by q dz by r, and find its two linearly independent solutions. This is equation number 2, and now we have to find the equation 2 solutions. So these are the two solutions, that 1 by x plus minus 1 by y is equal to c1 as the first solution, equation number 3, and consider this dx minus dy divided by this x square minus y square dz. That is the, you choose multipliers 1 minus 1 and 0, and in the place of each ratio consider the last ratio. We have this solution as the C2 as the equation number 4, and then equation 3 and 4 form the general solution of the, so equation 3 and 4 form the general solution of the auxiliary differential equation dx by p dy by q dz by r, this. And then the general solution of the given differential equation is what? F of uv is equal to 0, that is u is what? X into y by z. So or this equation either here three solutions are obtained, so out of three, take any two as u and v. So we can write this solution in this form: z is equal to x into y. Here from this we have z is equal to x into y, and then it is a function of x minus y by z. So we can write this, and z as x into y. So we can write this as the last solution, or this z is equal to x into y, g x minus y by x into y. So from this x into y by z, we have z is equal to x into y, and we have the function of x minus y by z. So and substitute z as x into y, so we have z is equal to x into y, g x minus y. So no need of this format. So write directly this as the last solution. This is the general solution of the given differential equation. Okay. So problem for homework, that again of the type PP plus QQ is equal to R. These are the problems of the form. This is this exercise from our textbook. So solve all these examples. All these are the Quasi linear differential equation, the differential equation of the form PP plus QQ is equal to R. Then find the integral surface of the linear partial differential equation is again PP plus QQ is equal to R, which contains the straight line of passing through the line x plus y is equal to 0 and z is equal to 1. So find first the general solution of the Gaussian linear differential equation, that is find equation 3 and 4, and then x plus y is equal to 0. So take x as t, y as minus t, and z as 1. So we have the relation between C1 and C2. Substitute these values of x, y, z in equation 3 and equation 4. This is equation 3 and this is equation number 4. And find the relation between C1 and C2, which is free from x, y, z. So if you observe this relation, 2C1 plus C2 plus 2 is equal to 0. This is free from x, y, z, t. So obtain the relation between C1 and C2, which is free from x, y, z, and then substitute C1 and C2. We have the general solution. We have the integral surface passing through the or containing the given curve. So same type problem. Find the integral surface of this again Cauchy linear differential equation passing through the circle z is equal to 0 and x square plus y square is equal to 2x. Already these problems are, some problem out of these are solved in previous lectures. So again the passing through the integral surface of this passing through the line x is equal to 1, y is equal to 0. Like x is equal to 1 and y is equal to 0. So then x into z is equal to a cube and y is 0. So x into z is a cube. So x is suppose t, then z is t by a cube by t. Okay. If we take x as t, then z is what? A cube by t and y is 0. So some problems are the general solution due to that is this is a solution. So all these examples, this is the solution of this differential equation. Find the general solution of this particular solution through the circle z is equal to 1, x square plus y square is equal to 1. So find first general solution that is the integral surface. And then now we have to find the integral surface passing through the circle z is equal to 1. That is substitute z is equal to 1 and x square plus y square is equal to 1. That is substitute x as cos t, y as sin t. Then again the same type problem. Passing through the curves. So first find its general solution, and then we have to find the passing through the curve. Y is equal to 0, z square is equal to 4ax, and y is equal to 0, z cube plus x, z plus a bracket square is equal to 0. So solve all these problems. Then this is the problem of formation of differential equation. Z is equal to x plus a, x square into y square plus b. Now we have to eliminate these arbitrary constants a and b. So suppose this is equation number 1. Now differentiate with respect to x and y, that are equation number 2 and 3, and from equation number 1, 2, 3 eliminate a, b, c by the addition subtraction. We have, this is the answer. So these are the problems of formation of differential equation. Again we have to eliminate a and b, with differentiate with respect to x, differentiate with respect to y, and then we have, this is the solution. So eliminate the arbitrary function f from each of the following problem and form the corresponding partial differential equation. Again, these are the problems of the formation of differential equation f of z minus xy comma x square plus y square is equal to 0. So this is the problem of the type f of uv is equal to 0. So u is z minus xy, v is x square plus y square. Then write the formula, that is p into del by uv divided by del by yz and plus q del by uv divided by del by zx is equal to del by uv del by xy. And then write find all the values of the Jacobians and substitute the values. So these are the problems of the type f of uv is equal to 0. So this is z is equal to f of x into y by z. So we have to eliminate this function f now. And for that we differentiate this with respect to x and with respect to y, and that are the equation number 2 and 3, and from equation number 2 and 3 eliminate this function f. So this is the problem of the type f of uv is equal to 0. Use the standard formula. This is again number 5 and 6 number problems are also of the same type. F of uv is equal to 0, right? This is u and this is v, and then write the standard formula of f of uv is equal to 0 and substitute the values of that Jacobians. We have the final answer. So these are again the problems of the formation of differential equation, partial differential equation. We have to eliminate the constants a and b. So to eliminate the constants, arbitrary parameters a and b, differentiate these equations with respect to x, with respect to y, and from the given equation and these two equations we have to eliminate the parameters, arbitrary parameters, that a and b, small a and b. So find the general solution of xp plus yq is equal to z. This is the type problem of the type pp plus qq is equal to r. Then write auxiliary equation and find two linearly independent solutions. Then f of uv is equal to 0 is the general solution. So how we can write this f of uv is equal to 0? So we can write z is equal to y function of x by y. So no need of writing this format. Directly this, write this as the last solution. Find the general solution. Again is the problem of the same type, pp plus qq is equal to r. So solution is given. This is the solution. Next problem is again of the same type and the solution is given. This is the solution of the problem. Next is zt plus zx is equal to. Actually this is the problem in the variable z x and t. Z x and t in the place of x y z. The variables are x, z and t. So delete this problem number 1.4.4. Don't write this problem. Find the general solution. Find the general solution or general integrals of. So again the problem of the type pp plus qq is equal to r. The solutions are given. Solve all these problems. So question is what? Find the general solution or find the integral. Find the general integral or find the integral surface of the type pp plus qq is equal to r. So these are the problems of the integral surface passing through the given curve. So this is the problem passing through the integral, passing through the line x naught s is equal to 1, y naught s is equal to 0, z naught s is equal to 1. So answer is given. Find the general solution of the Cauchy linear differential equation and then find the relation between C1 and C2. So the next problem is again of the same type, passing through the curve x naught is equal to 1, y naught is s, z naught is s, 1 plus s. So the answer is given. So this is the required answer, required integral surface. Find the complete integral of this. Again is the p square plus q square x is equal to. So the auxiliary equation is this. So eliminate this problem 1.9.3. Don't consider this problem. This is from out of syllabus. Then also delete 1.9.4. Then solve all these problems passing through the, these are the exercises. 1.9.1, passing through the curve z is equal to 1, x square plus y square is equal to 1. So solve all these problems. So these are again the problems of the type Pp plus Qq is equal to R. So consider this problem. Solution is given, Pp plus Qq is equal to R. So write all these problems in your notebook. This is again Pp plus Qq is equal to R. So write auxiliary equation, then find their two linearly independent solutions, then f of, here is the notation phi, right? F in the place of phi, right? F of uv is equal to 0 is the solution. So these are all solve problems of the type Pp plus Qq is equal to R. These are problems for exercise. Pp plus Qq is equal to R. Their solutions are also given. In the place of phi, write capital F. Then these are also the problems of the same type. Pp plus Qq is equal to R. And write the auxiliary equation dx by p dy by q dz by R. And now this is the repetition of the topic, first topic, that the problems of the type dx by p dy by q dz by R. So write all these solve problems in your notebook and solve the exercise problems. So actually these rules, type 1, type 2, type 3, rule base, rule on 3, rule on this, means these are the rules of the finding general solution of the differential equation of the type dx by p dy by q dz by. You know that there are two basic methods to find the general solution of dx by p dy by q dz by. That is by considering two ratios or by choosing multipliers. So these are the problems of the actual type dx by p dy by q dz by r. That depends on the type. So these are all the problems of the Cauchy linear differential equation Pp plus Qq is equal to R. So write all these problems and their solutions and solve the exercise problems. This fourth rule means actually these are the rules to obtain the general solution of the auxiliary equation dx by p dy by q dz by r. That is the multipliers, method of multipliers. So while solving this type problem pp plus qq plus r, we have to solve the differential equation of the type dx by p dy by q dz by r. So this is actually the repetition of the first topic, integral surface passing through the given curve. So these are the problems of the type find the integral surface passing through the given curve or containing the line, containing the curve. So write all these solve problems and solve all these exercise problems. Answers are given. This is not, these all problems are not our, not from our uh, referred textbook. This is, these all problems are for practice. So solve all these problems, find the integral surface passing through the given curve. And so while solving these problems, we have to solve the equation of the type dx by p dy by q dz by r. Means this topic covers two topics, the previous topic dx by p dy by q dz by r. So we'll start the next topic in the next lecture.